All right, we're back. So once we found these two angles, what that means is that, or the reason that we had to do that was because there are two possible angles that angle A can be, because there are complementary angles here. Now, if we look at the picture, it looks like a pretty big angle. So the picture to me looks like it's probably 140.6, but that's not what they're asking you. You can't rely on the picture. Maybe they just drew a bad picture, right? So when you're using the sine law to find an angle, regardless of what the picture looks like, you still have to find both those angles. So what that means is we actually have two triangles, right? So we have, let's just move this out of the way here. So we actually have this triangle here, where this is 39.4 degrees and this is 23 degrees. And we also have the same triangle where this is 140.6 degrees, this is 23 degrees. And then this is our angle C up here that we can also find. So when we have to solve our triangle, that means we're finding all the sides and all of the angles. So we can go ahead and use the sine law again to find this side, side C, once we know what this other angle C is. But remember that we have two triangles. So that means that in this case, this is A, this is B. So in this triangle, we have angle B is 23 degrees, angle A is 140.6, angle C will be whatever, angle C is going to be 180 minus 140.6 minus 23 degrees, so whatever that equals, you'll work that out on your calculator. And
16.4.
16.4 degrees, okay,
so.
Something like that, sounds good to me. All right, so that's angle C when angle A is 140.6. But in this triangle, we have angle A is 39.4, angle B is 23, angle C here will be 180 degrees minus 39.4 minus 23 degrees, and you'll use your calculators to figure out whatever that is, and that'll give us another measurement for angle C. So we have two different values for angle A and two different values for angle C, where angle B stayed at 23 degrees. Right. Why did I take 180 degrees and subtract these two angles?
Because the triangle has 180 degrees.
Right, because inside the triangle, all the angles of a triangle add up to 180 degrees. We know that law from previous examples. Yeah? Yep. Awesome. All right. Let's do one more example. And we'll jump on to this next picture here. Yeah, that's the one. All right. So we have a house. Good carpentry question. So the roof of a house has two slanted sections. That would make a roof. Yes, it would. Right. Flat roof, not so good. Right. Roofing cap is being made to fit the crown of the roof where the two slanted sections meet. So that means right in here. Right. Determine the measure of the angle needed for the roofing cap to the nearest tenth of a degree. So what I like to do is I like to take this triangle shape out, isolate it so we can actually see what we have. All right, get rid of the house. So down here we have this house here where this roof is 20.3 feet and this side is 17 feet and this side looks like 33.5 feet. All right, and what we're trying to find is this little angle in here, right? So I'm just going to put some letters in here so we can kind of make this triangle TZE, EZT, TZ, ZT, doesn't matter what it's called, right? Alright, so, do we know angle T?
No.
Do we know angle E? No.
No.
Don't know this one. This is the one we're trying to find out. Alright? We do happen to know all three sides. Right? So side, side, side information. Can we use our law of sines?
No.
Why not?
Because we have no angles.
Because we don't know any angles. Perfect, yes. Alright, so we're going to use our law of cos. So our law of cos says that the side that we're trying to find is equal to the square of the other two sides added together, minus 2 times those two sides, and the cos of the angle for the side that we don't, or the side that we have, yeah, across from the angle that we're trying to find. So in this case, we need to find angle Z. Right? So what we're going to do is we're going to use this, which is my side Z, and across from here, this is side E, little e, and across from here is side T, little t, yeah? All right, so we know that side Z squared is equal to, well actually first off I'm going to give you the formula. We'll give you this formula, plus b squared minus 2ab cos c, right? So you remember our relationship that the side and the angle opposite that side is the end part of the side of our formula, right? So whether we start with A or B or C, it doesn't really matter. In this case, we're going to use Z. So we'll use the letters that we have in our triangle that's identified. So Z squared will be equal to T squared plus E squared minus 2 times side T times side E times the cosine of angle Z, because that's what we started with over here with side Z. Yeah? Alright, perfect. So, plugging in our numbers, and I'm just going to pull this out because we don't have time to do this. We're just reviewing here. Alright, so let's go down to there. Perfect. Let's clean this up a little bit. So, we took our 33.5 squared side minus the, squared is 17 squared plus 20.3 squared minus 2 times 17 times 20.3 times the cos of, well, that angle Z that we don't know. Alright, so I work out my numbers, and actually I am going to actually write this out. So let's just move this over here, back over here, just so that you guys can follow the steps. So we had, I'm just going to write this out quick, 33.5 squared is equal to 17 squared plus 20 squared minus 2 times 17 times 20.3 times the cosine of Z. I don't know where it is. Okay, so that's what we had. So I want just to remind you, because we have this negative sign in here, and we have our plus sign in here, our addition sign, all right, we have to isolate what it is that we're trying to find. So we are going to be trying to find cos Z, right? So this is the thing that we need all by itself. Right? So what we're going to do is anything that has that part in it is we're going to bring it over to the other side and leave it there. All right? So a couple different ways of doing this. You can put in the actual number, do the calculations, and then bring all your stuff across, or we can just bring it across and do it as an equation as we go. Right? So, if we go back to our formula, I'm going to use the letters that we had before. Z squared equals T squared plus E squared minus 2 times T times E cosine of z. Alright. So, we're going to manipulate our formula a little bit so that we get in our formula, we end up getting z squared minus t squared minus e squared, because we're bringing this to this side, we're bringing this to this side, and whenever we bring addition or subtraction across the equal sign, we always change the sign, or in other words, if we're adding on this side, we subtract from this side, we must subtract it from that side, because what we do with on one side, we have to do on the other side to keep everything equal, all right? So that leaves us with negative 2te times e times the cosine of z. Okay. Like so. Now, this operation is negative 2 times whatever side t is, whatever side times the side of e times the cosine of z. What's the opposite of addition?
Division.
No, addition.
Oh, subtraction?
Subtraction, right? And that's why these were adding, so we subtracted them onto this side. Now we have multiplication, and you're right, what's the opposite of multiplication?
Division.
Division. So we are going to have to divide to get rid of this stuff, because what we want is this cos z all by itself, right? So what do we need to divide to get rid of negative 2 times t times e on this side?
Negative 2 times t times e.
Right, so we're going to take this and we're going to actually just divide this by negative 2 times t times e, and that'll leave me with cos z on that side, right? Yeah?
Yeah.
Makes sense, all right. So, I'm just gonna, can we just touch this here? Okay, beautiful, all right. So, I'm gonna move this up a little bit, or I'm just gonna work up here now. So, in our formula then, we will have 33.5 squared minus 17 squared minus 20.3 squared, right, divided by negative 2 times 17 times 20.3 is equal to the cosine of our angle z over here, right? So, you have to remember that your calculator is not that smart, okay? It's only as smart as the person putting in the values. So, depending on the calculator, some calculators can handle doing multiple operations with brackets and everything else, but really it relies on the person that's typing it in. So what you're going to need to do is figure out this part of the equation as all one big chunk on your calculator. Write down that answer. Okay. Then you need to take this part and figure it out on your calculator as one big chunk and write down the answer. Right? So, we're just going to go back up to here, because I don't know what the, let's see, just pull this thing out so that I can get the numbers off of it. And what do we have, 421, okay, so 421.6 divided by negative 690.2 is equal to cos z. Okay, let's just move that back. Okay. All right, so that's what we did. So we figured this out, was 421.6. This is negative 690.2 is equal to the cosine of z. Now, the opposite of finding an angle on our calculator is we have to take the second function, cos in this case, which gives us our cos negative 1 of 421.6 divided by negative, gotta push your negative button, 690.2, close your bracket probably, and that is going to equal angle z. Okay? And if we just go back up to computer for a second. And pull this out, get our values. Okay. And we have right, so cos -1, 421.16 divided by -690.2. We get 127.6039. So angle Z is equal to 127.6. We'll go up to 1 degrees. Let's move this out of the way. Yeah, there we go. All right. 127.6 degrees is this angle in here, our roof cap, yeah?
Right.
Okay. So that's using the law of cos. Now, we do not have to find the 180 minus 127.6 degrees, because that would give us a negative angle, and there's no way we could have a negative angle to build a roof. Unless the roof's upside down, maybe. Right? Put it on the wrong, we're building an arc instead of a, no, I'm just kidding. Right? Questions?
No.
Well, right. Let's go up, move this up a little bit. Yeah, let's jump to this one. So, careful when using your sine law. Make sure that you have to find the other angle and solve the two triangles. Right? There's always going to be two triangles. Let's assume there's two triangles. Right? With cosine law, you do not have to find its supplement because they're not equal, they're opposites. Okay? So, cosine law, if you use the law of cos, you only have to solve one triangle. Use the law of sines, you probably have two triangles. Okay? Ambiguous case. Let's move this up a little bit. Okay. So, we're going to stop there. Ambiguous case, we looked at ambiguous case already. Okay, so we're going to pause we're going to stop the video in a minute, and then we'll come back to what we're going to look at today.